you'll enjoy this. In case you're wondering who I am, I'm Stephanie Menjivar. I'm the growth manager here at IronHack US, and I'm here with our data analytics instructor, Himanshu. Himanshu, go ahead and tell the crowd who you are and what you do.
Yes. Just 1 second. I'm still having some technical difficulties over here, but yeah, it's all good now. It seems. Okay. Hello, everyone. Sorry about that. Yeah, my name is Himanshu. I'm the lead data analytics instructor at IronHack in the Miami campus. Welcome all, and thank you so much for being so patient. We're going to get started in a couple of minutes, and before we start, Stephanie, is there anything that you want to add, or can we just start now?
Yeah, sure. So just to let you know how this platform works, right under where you are watching us, there is a little toolbar. In that toolbar, you'll be able to maximize windows, minimize windows. You'll be able to access the attendee chat and also the Q&A section. If at any point in time there's something weird going on, if there's some weird technical difficulties, if you can't hear us, let us know in the chat so we can troubleshoot. I'll also be sharing some resources towards the end of the presentation in the chat. And of course, please don't hesitate to ask questions and let us know if you're enjoying this workshop. So with that being said, Himanshu, take the lead.
Thank you, Steph. Yeah, I'm going to start sharing my screen, and please let me know if you can see the screen. Is it visible?
Yep.
Okay. All right. All right. So the agenda for today is introduction to machine learning, as Stephanie was saying. I mean, everybody knows that machine learning, AI is the hot topic right now. So today we are going to talk about just the fundamentals or the basics of machine learning, like what it is, how does it differ from AI. Sometimes all of these words are used synonymously. For example, when you talk about AI or machine learning or deep learning, data science, all of these terms are sometimes used synonymously, like I said. So we are going to talk about what is the difference between these so-called buzzwords and where does machine learning stand in here, and then what are the techniques, how do we work with machine learning problems, and what kind of questions does machine learning solve. So to begin with, we'll start with AI. So if you want to think about it, think about AI as the bigger umbrella under which there is machine learning. And then again, inside machine learning, you can think about deep learning as a subset of machine learning. So on the very top, you can say that you see AI. Then inside that, you can say you have machine learning, and then inside that, you can say you have deep learning. So artificial intelligence, if you want to talk about it, so is essentially the science of making things smart. So we are trying to make the machine behave as a human being would. And this is done, of course, by programming the machines. And this programming is done in many different languages. Python is one of the more popular languages recently because of the vast variety of libraries that are available for us. So Python is not just used for machine learning or data science. It can be used for game development. It can be used for web development. Like you can design proper websites. There are frameworks, Django and Flask, which are the two most popular frameworks in Python that you can use for uh, the front end development as well. So there are multiple applications. I mean, you can do web scraping. You can create your applications in Python. So all of that we can do in Python. So artificial intelligence has. I mean, everybody has seen multiple applications of artificial intelligence around them. So if you think about a chatbot, if you think about, I mean, chat GPT is so popular right now. If you talk about automated driving, autonomous driving, all of these are examples of artificial intelligence. The programs have been written in such a way that the machines behave like a human would. So they're trying to replicate the human intelligence artificially. So that is AI. So a subset of that is machine learning. So machine learning typically caters to a specific kind of problem. So machine learning is more about understanding patterns in the data to make the machine understand those patterns, and then we take decisions based on those. So that is called data driven decision making. So in machine learning, there are two different kind. I mean, there are different kinds of problems that you try to uh, answer. So when you make predictions, for example, so when we talk about a machine learning model that makes predictions, that is a simple application of machine learning. There are many other applications of machine learning that go beyond just predictions. So we'll talk about one of those examples in today's session. So understanding data and then learning from the patterns inside that data, that is about machine learning. And when you start using neural networks to achieve the same objectives, like understanding patterns from the data, that is called as deep learning. So neural networks are so very popular right now. Convolutional neural networks are very popular. There are different kinds of neural networks that are there. I mean, image classification is such a breakthrough in deep learning. I mean, it was such a breakthrough in deep learning. So by looking at the image, you can actually classify whether the image is of a human or if it is of some other animal. By looking at the image, you can classify what the object is actually. So that is all applications of neural networks. So machine learning is, like we discussed, is about understanding the patterns from the data. It could be used to make predictions. It can be used for image classification. It can be used for clustering. It can be used for uh, reduction of. I mean, sometimes you work with a massive amount of data, so it can also be used for dimensionality reduction. There are many applications, or there are many algorithms that you can use that have all those applications. So machine learning is that big bucket of algorithms and everything, all the techniques and technologies that are developed to answer questions based on understanding patterns from the data. Right. So data is very important here. So when we talk about machine learning, we talk about predictions very often. So, for example, we talk about what would be the price of a stock tomorrow, what would be the price of a stock in a week, right? Given a certain set of features, can we say whether this person would be a good person to give a credit card or not? I mean, whether this person would default or not, right? Given the climatic conditions of a certain area, we can make a prediction on the rain. Weather forecast uh, is so common. I mean, like you see it on news channels, you see it on your mobile applications. It's everywhere, right? So to discuss what machine learning is, we need to understand two main terms here. So one of the terms is supervised learning, and one another term is unsupervised learning. So when you talk about supervised learning, you're trying to understand the data. At the same time, you have some target that you are trying to make a prediction on. So basically, when I say I'm trying to make a prediction on the price of a stock, for that, in order to make that prediction, I need to have the historical data. I need to have data for, let's say, 5 years, 6 years of how that stock has been performing over time. So that is my historical data based on which the model will learn and will make predictions. And if you think about a very common application is like if you want to, so for example, when you use your everybody uses a credit card. So when you apply for a new credit card, there's an online application that you fill in. It asks you for some pieces of information, and based on that information, it gives you an instantaneous result on whether your credit card is approved or not. So what does the machine do? I mean, the application, it takes in your information, it processes that information, and based on a model that has been created, it makes a prediction on whether you will default or not. So that is another yet another application of machine learning, right? So whenever we talk about machine learning, so we talk about either supervised learning or unsupervised learning. There is also reinforcement learning, but typically we talk more or less about supervised and unsupervised in the beginning. So let's say for the fundamental part. So When you talk about supervised learning, there is a target in your mind. So you're trying to make a prediction on something. So for example, if you're trying to make a prediction on the price of a house, for example, if you say that, okay, this house has 4 rooms, it's in this zip code, it has a parking lot, there's waterfront, there's no waterfront, and all these things, this is the square footage, etc. Given these parameters, can you tell me what the price of a house would be? So how does that model work? That model takes in a huge amount of information, which is called as the historical data, and that historical data contains information about thousands and thousands of homes, and those homes for which you have the prices for, right? So for example, if you go to a Redfin or Zillow, so they have a database of different homes at what prices they are. So let's say if I want to make a prediction on what the price of a house, of what the price of a similar house would be, so I would need to create a model like that, that can understand the data, that can understand the pattern from the historical data. Or I'm using the word historical because the data that you use to create the model is called historical data, because that's the past information. So what does the model do? The model understands the patterns within the data. So I'm emphasizing the word patterns a lot because this is what the machine learning model does. So let's say, given this example, we are trying to find the profiles of customers for of car insurance most likely to purchase home insurance from the same provider. So these are some features that are given to you. So based on this, you will try to train your model, right? Because we are trying to understand the patterns in the data, which can also be said as you're trying to train the model. So the model will understand the data. That is called the training part. So you will train the model, and based on that training, so when the model trains, when you train the model, what the model tries to do is it tries to identify, okay, how important is the name, how important is the occupation, how important is the age. It assesses each and every feature in your data, and then based on that it computes that, okay, if somebody tells me that this is a new record, this is a new piece of information, what would be the prediction for such a case? This is what the model tries to understand. For it tries to understand the changes in why is your target, the thing that you're trying to make a prediction on, right? That is the target. So it tries to understand the changes in y with respect to changes in x. So in mathematics, what we say is you're trying to understand the variation is x, based on the changes in y, and vice versa. So you're trying to understand their relationship with each other. How does my target change with respect to change in x? So this is what the model tries to understand essentially, like mathematically, right? In order to build that model, we need to write a bunch of lines of code, and that we do it in Python. So we'll go over what is the process that we use in order to create such a model that can take in historical data, understand that data, and then give out predictions for the future. Right? So this is the whole objective of machine learning, and this is what we will do through an example. If there are any questions, please don't hesitate to ask. You can put your questions in the chat window, and then Stephanie can relay those questions to me because I can't see the other window right now. Okay. So
right now, somebody did ask if there will be a recording, so yes. But other than that, we can keep going.
Okay, cool. So like we were discussing, this machine learning can be either supervised or unsupervised. Whenever you have a target that you're trying to make a prediction on, so that those kinds of machine learning models are called supervised machine learning models, right? And the kind of models where there is no prediction as such, there is no target. So there are other applications. So for example, you would want to cluster the data, group the data. For example, let's talk about an application of customer segmentation. So customer segmentation is what? So basically, let's say you own a company, and then you sell a particular product. That product is bought by thousands and thousands of customers. So what you want to understand is how do my customers, or what are the different segments in my customers, so that I can uh, target them individually. For example, there would be a certain set of customers with similar characteristics. For example, they would be people. So let's say the product that you sell is a book, or like you sell books, right? So what different kind of clusters can you make? So for example, there would be uh, a cluster of people, let's say from age 17 to 23, that would like to read certain kinds of books. There would be younger people who would like to read certain kinds of books. There would be older generation that would like to read more spiritual books, let's say. There would be people who are in their 30s and in the 40s who would like to read more I mean, the books that will help them with financial success or whatever, right? So there are different clusters, or there are different uh, customers with different behaviors. So in order for you to increase your sales further, what you can do is you can do some targeted marketing. In order to understand those targets, you can do some clustering. So you can do some grouping based on the data that understands which customer is similar to the other customer. So there are many examples like that. So this is what unsupervised learning is. You are not trying to make a prediction. You don't have a target variable in this case, right? So clustering is one of the examples. So then dimensionality reduction, there are other things that you can do with unsupervised learning. So today what we are going to focus on is regression. So when you talk about supervised learning, we said that there is a target that you're trying to make a prediction on, right? That target could be a numerical value. For example, we said when you're trying to make a prediction on the price of a stock, the price of a stock would be in dollars, right? If you're trying to make a prediction on the price of a house, that would be also be in dollars, right? If you're trying to make a prediction on a target which is not numerical and which is not continuous actually, so that those supervised learning models are known as classification models. So in this case, the target is not continuous, but it is categorical in nature. For example, when we say whether somebody would default or not based on the historical information of their, let's say, credit history, their financial information, you're trying to make a prediction on whether somebody would default or not. The target is binary in nature in this case, whether either the person will default or the person will not, right? So the target is binary in nature. So that those classification models are called binary classification problems. Then there are also multi-class classification problems. Let's say based on the uh, image of a number, you are trying to make a prediction what the number actually is. In that case, the number could be either 0 or 1 or 2 or 9. I mean, like all the numbers that are there, right? So in that case, your target are not just two. There are more than two targets, right? So in that case, those kind of classification models are called as multi-class classification problems. Then there is another category of classification problems which is called as multi-label, multi-class. Let's say you have some data. Let's say you're working for Netflix and you're trying to uh, classify some movies. So the movies can be classified as, let's say, there are two levels of classification. The first level is whether this is an adult movie or not. And like, for example, the rating of a movie. What is the rating of a movie? And then you say, what is the category of movie? Like, is it a comedy? Is it a romantic? Is it an action movie or whatever it is, right? So there are two levels of decision making there in that case, right? A movie, is it either an action movie or it's a comedy or whatever? And also, what kind of a rating does the movie have? Those sorts of problems are called as multi-label, multi-class. So that is classification. The whole idea is about the target. If the target is categorical in nature, like it is distinct, right? Then in that case, it is a classification problem. If your target is continuous, then it is called as a regression problem. And here they both are a subset of or not a subset, I mean like they both are a part of supervised learning algorithms, because there is a target on which you're trying to make a prediction. So there is some sort of prediction involved in this machine learning, right? So these are supervised learning models, right? uh, so these are some more examples, like classification, yes or no. So if it is a binary classification problem, then your output is binary. It could be yes or no, 1 0, true false, either or. I mean, it could be anything. So as long as your target is binary, then it is a classification I mean, sorry, it is a binary classification problem. There could be many other forms of classification problem also. And for example, if you talk about regression, sales of a company, so sales of a company, or like sales of a particular product in a company, let's say how many ice creams would this brand sell this week, right? Stock price. So all both of these are examples of regression problems, right? Unsupervised, we don't know what the output should be, or what we don't know what the target is. There's no target as such, right? So for example, customer clustering, so you're trying to divide the customers into groups of 4, and each group will have customers which will have similar characteristics or similar properties, similar attributes, right? So this is the idea behind supervised and unsupervised. Okay. uh, a typical workflow when we actually create the model is fairly simple. So whenever you think about machine learning, there's always some objective, right? I mean, we cannot start working on a problem without defining the problem. So the first step is you define what your objective is. Based on the objectives, you gather the relevant data. After you gather the relevant data, it's about understanding the data, then cleaning the data. After you clean the data, after you understand, so which is that part is also called as EDA, or exploratory data analysis. Then there is a processing step where you make the model, or where you make the data acceptable for the model. So sometimes you get data as strings, sometimes you get data as numbers in different scales. So you have to manipulate that in order for the data to be ready to be sent to the model. So that part is called as pre-processing. And after that, you begin your training. So if you look at this flowchart here, so you have source, you can have like multiple sources, and then you can aggregate data from multiple sources. That is called as data extraction. So you are gathering the data. ETL, extraction, transformation, loading. So this part of the process is typically taken care of by data engineers. So this could be ETL process, extraction, transformation, loading, or it could be ELT, extraction, load, and transformation. So the data engineers are more into this part of the process. After the data is ready in a data warehouse, then you can start pulling the data and then analyzing that data. So this is that part over here. So you pull some of the data, you train the model based on that. After you train the model, you test the model. So before you use your model into a production environment, you would want to test it out. I mean, you want to see how good or how bad your model is. And that is done through testing of the model, right? So this testing is based on different kinds of accuracy measures or quality metrics. So if it is a regression problem, there are different kinds of measures based on which you assess the quality of a model, or assess the accuracy of a model, to be more precise. So for example, there is mean square error, root mean square error, R square, adjusted R square for regression problems. There are many other methods as well. If it is about classification problems, then there are different kinds of testing measures or quality measures or accuracy measures. So for example, there is confusion matrix, there is ROC AUC curves, there is kappa score. There are all of these different measures based on which you can evaluate how good or how bad your model is. So today we are going to talk about a regression problem. We'll calculate the accuracy and we'll see how the whole process works. So extraction, transformation, loading, this is more for, I mean, this could be thought of as gathering of all the data that is relevant for your analysis. So nowadays, the words like data lake, data warehouse, data marts, all of them are very popular. So basically a data lake is a data dump. So from any source that you're getting, you can get data from like different kinds of sensors, IoT devices, flat files, like there are some applications that are generating some log files, etc., etc. There could be hundreds of resources. There could be audio files, video files, etc. All those sources, they just put a data in a data dump, which is called as a data lake typically. So from the data lake, you start the process of extracting that data. So that could be called as ELT or ETL, extraction, transformation, load, or extraction, load, transformation. There's different ways in which you can go about it depending on like what the architecture of your what architecture are you using, what frameworks are you using, etc., etc. Right. So after that, we come to this part where we load the data and then we start working with that data. So this is that part of uh, ELT. So when you get the data, you clean the data, now the data is ready to be trained, then there's an important step that we do in supervised learning models, which is called as a train test split. So a train test split is what? Basically, it splits the data into a training data and a test data, or you can call it as a training set or a test set. The training set is used to train the model, right? Because the model needs to understand the patterns in the data. So you need a huge amount of information to train the model also. So you have some training data, and then you keep away some portion of the data from your data set, and you call it your test set or test data. So this test data is what we use to assess the accuracy of the model. So the training set is used to train the model. The test set is used to test the accuracy of the model, how good or how bad your model is, so that you can go back and change some of the steps and try to improve the accuracy of your model, right? So there are different methods. There's cross validation. There's different kinds of cross validation methods, which you would learn as you will deep dive into these topics. I mean, of course, there's tons of information. So what we are covering today is a very basic overview of machine learning. So when you do a train test split, there's always I mean, you can say that 70% of my data is I'm reserving for training the model. 30% of my data is I'm reserving for testing the model. So there is no rule of thumb as in this 70-30 is the best ratio, or 80-20 is the best ratio, or 60-40 is the best ratio, depending on how much data you have and how much data you can use for training. I mean, you will decide on this percentage. I mean, like how much data you want to use for your training set. And then if you're trying to go for cross validation, then this percentage even reduces further. And then this is an important step because this helps you understand when you check the accuracy of your model. This helps you understand if your model is doing good or bad, right? By checking the accuracy. It also helps us understand whether the model is over complex, which we call it as uh, a high variance model, or if your model is uh, oversimplified, which is called as a high bias model. So there's always this thing that you have to check. I mean, is your model oversimplified? Oversimplified models are sometimes are also called as underfitted models. So underfitted models or overfitted models, like these are some important terms that you'll come across as you will learn more and more. So all of this is important to understand and correct your model, right? So when we do this train test split, all this validation, cross validation, this is important. This is very important for those stages. So there are different kinds of algorithms that you can use for different kinds of problems. So if it is a regression problem, you can use linear regression, you can use decision trees, you can use random forest. Some of the names you will find them in both regression and in classification, because the way those models work, they can be used to make a prediction on uh, whether, I mean, like, even if the target is numerical or if the target is categorical, though those particular models, they still work. So some of the names are common here. So when you talk about regression problems and classification problems, we're talking about supervised learning, right? So this is supervised learning. So there's always a target, and your target is what you're trying to make a prediction on, essentially, right? So this is what supervised learning models are. And when you talk about unsupervised machine learning models, there is no target, right? So you don't know what you're trying to, you don't know exactly what your prediction, not prediction, I mean, what your output will be, but you're trying to understand the data based on some mathematical quantities. So for example, when you use clustering methods, there is a similarity index that you measure based on the distances, etc. There's also this time series forecasting, which is a bit different than regression problems because it is an entire field in itself, in the way that these different models like ARMA, ARIMA, SARIMAX, like ARMA is auto-regressive moving average. So this is a separate field in itself because once you have a time-based data collection, I mean, if it is a time series data, then there is autocorrelation, and then you won't be able to use simple linear regression or decision trees there. Neural networks work on time series data, but there are some models that have been developed specifically for them. So these are those names. There are a lot of other time series forecasting models as well. So uh, before we jump into the code, like how this is all implemented in Python, does anybody have any question in the basic understanding of supervised learning versus unsupervised learning, or regression versus classification, anything?
Well, we'll wait for some of these questions to come in since it's a little delayed on our side. But I have a question for you, Himanshu.
Yes.
What kind of model is the OpenAI API using for these ChatGPT or the DALI tests that they're doing?
So for OpenAI or ChatGPT, it is more about natural language processing, so NLP. So if you are interested in that area, NLP is different than regression problems or classification problems. I mean, it is also a part of machine learning, but it is natural language processing is more about understanding the text. So there are different models that are used. I mean, the models that you would see, for example, one of the very popular model is called LDP, latent, or LDA, latent dirichlet analysis. So there are many other models that have been developed, but I mean, so this Open AI, this Chat GPT, these are way more advanced model than way more advanced than just using some simple NLP also. But I mean, the core or the idea is natural language processing. Since they are working in like huge numbers with huge investments, I mean, obviously they're doing a lot of research and like developing those different algorithms, and modifying them the way to suit their purpose better. And of course, they're working with terabytes and terabytes of data, but at the core, it is about understanding the texts. And if you want to work on such problems, it is NLP, natural language processing.
Very cool. We have a question here from David. He says, how much data is sufficient for training? For example, in image classification, how many images are sufficient?
So you cannot put a number to this question, honestly, because ideally, the more information you have, the more your model can learn. And an important concept is making your model more generalized. So when you will read more about machine learning models, you'll learn what is overfitting, what is underfitting, what are generalized models. So you are essentially trying to make a good out of the box prediction. So the larger your data set could be, the better it is for you, for your model. It'll be more reliable. So accuracy and reliability are two things that we should be careful about. Sometimes a model can give you a false idea of higher accuracy, but the model might not be reliable. So we need huge amounts of information. The more, the better, to put it in simple words.
He also asked, how is data drift handled?
Data drift, I mean, if you can give a specific example of what you mean by data drift here.
I'll wait for that to come in and I'll go to the next question. How do you determine how important is some value in a machine learning model? This one's from Israel.
So it's not about a value. It's about, I mean, I suppose the question is about which features are important. So when we are trying to make a prediction, you work with a feature set. So that is your X, or I mean, you call it X, or you can call it independent variables. There are multiple names that you can use. The feature set is what we are trying to understand. I mean, like which features are more important, which are not. Sometimes you can work with 100 features or 1,000 features, doesn't matter. So there are different techniques to understand uh, which features are more important. Some techniques are more automated. For example, there is recursive feature elimination. Some techniques are more based on analysis of the data. For example, you can use a simple bar plot to understand data. You can use for example, different kinds of correlation indexes. So correlations can be checked for numerical variables. You can create a heat map. You can check for multicollinearity. This is the way you can uh, check whether a particular column is important or not. And then there are some algorithms. For example, you see random forest here. So random forest is an algorithm which is based on bagging and boosting. So there are some algorithms that inherently give importance to the more important features. So if a feature is more important, they will outshine as in they will be given more importance in the algorithm itself. So when you learn about random forest, this is something that you will find out, for example. So there are different techniques by which you do feature selection.
Awesome. And to follow up on that previous question, which was how is data drift handled?
Yes.
David adds the input varies over time, resulting in model accuracy degradation. So I'm guessing he's asking something regarding that.
I'm sorry, what did you say? Input varying with time?
Input varies over time, resulting in model accuracy degradation.
If your input is varying with time, I mean, if you're trying to continuously update your model, I mean, that's a different thing. So, for example, my understanding of this question is, for example, let's say you train your model at instance A, and after that time, let's say after some time has passed, there's more data that was collected, and you want to use more information to train that model. So, I suppose when you build a pipeline, you already accommodate for that thing. I mean, if you want to add more data to your training set, but yeah, depends on how you want to work in that situation. I mean, how frequently do you want to keep on uh, changing your model? Because typically when you train, I mean, it's a long process, and you can do it at different frequencies. You can do it, let's say, daily, weekly, monthly, or hourly, or instantaneously. It depends on how you would want to uh, change your model and how frequently you would want to change your model.
All right. And then we have one last question. Probably the most interesting question out of all of these is in plant disease detection, does it use unsupervised or supervised machine learning models?
So plant disease detection. So it sounds like a classification problem. I mean, the thing that distinguishes supervised from unsupervised is if there is a target that you're trying to make a prediction on. So if in your data you already have the labels. So for example, given these set of features, this plant had disease A. Given these set of features, this plant had disease B, and so on. If you have the data labeled, then it'll be a supervised learning problem and it'll be a classification problem. I mean, if the data is not labeled, I'm not sure how you would be able to make a prediction on whether the, the plant has a specific disease or not. So I think it'll be supervised and the data has to be labeled.
All right, so that covers all our questions. We can move on to the more practical side of the workshop.
Awesome. And is the screen still there? I mean, is my screen?
Yeah. Oh, yeah.
Okay.
Go back. We just had that one. Yep.
Okay. So in this case, we are going to work on a regression problem. So the idea is to show you a quick implementation on how you would create a simple model in Python. So in this case, we are importing a couple of libraries. We are going to use more libraries later on. So pandas and numpy. So pandas is used for working with data frames, and numpy is used for working on matrices, arrays, and doing some algebra matrix calculations. So we have the data, and then this data is, let me see, this is, this is the data. So in this case, what we're trying to make a prediction is, oops, sorry, this window is behaving weirdly. Okay, so yes, so based on some information here, we are trying to make a prediction on what will be the claim amount of a person. So for example, here's some information which is given to us, like customer lifetime value, income, monthly premium order, etc., etc. So all of these records, so a row in data is also called as a record. So every record basically corresponds to a particular claim amount, right? And in this case, what we're trying to do is we are trying to create a model so that based on these features, can we make a prediction on what will be the total claim amount. So this is a numerical value, and in this case, this becomes a regression problem. So it's a very simple model that we're going to make. The first step that we do is we separate out the numericals and the categoricals. So for the numericals, we're using this select d types np.number. So this extracts all the columns which are numerical d types. D types as in the data types. And there is categoricals. So we are separating out the numerical and the categorical. In this case, there's not much data cleaning that we're going to do. This is a simpler implementation. And this is what the numerical columns are. And this is all of our categorical columns. So it's the single data frame. I mean, it's a single table where you have a target column, and all the rest of the columns are considered as a features. So we will use all the features to make a prediction on the target, right? And this feature set has data in it, right? So this data can either be numerical or categorical. So the reason why we're separating out numerical and categorical is because later on, when we train the model cannot understand these string values, right? We need to convert these string values into numbers somehow so that the model can perform its calculations that it needs to. So for that part, we separate out the categoricals and we do a process which is called as one-hot encoding. So one-hot encoding converts these different columns which are categorical into numerical values, which is zeros and ones, and it does it intelligent. I mean, like the way it does is, it's another topic of discussion. For the numerical data, you see that there are different scales in which these measurements have been taken. So that is the reason why we scale this data, so that the different columns that are there's no bias between the numerical columns based on the scale of their values. So this is a typical process that you would do in any machine learning model. So after we do this, we convert everything, we scale the we scale the numericals, we encode the categoricals, we put them back together, and this is our new feature set. New feature set as in the processed feature set, right? After that, you do a train test split to split out the training set and the test set, and based on the training set, this is the single line of code, for example, train test split, and this is test size. So in this case, we are choosing test set to be 40% of the data, and training set will be 60% of the data. So when you do a train test split, what you are doing is you are reserving this training data for training the model, and this test data to test the accuracy to see how good or how bad your model is. In this case, we can use a simple linear regression. So we are using the sklearn library to import linear regression, and this is the model definition. Honestly, like a single line of code, this is the simplest definition of linear regression. So we are using all the default parameters. We are not changing any parameter here. So this parenthesis is empty. So after you define this model, you fit the training data to the model. So model.fit does that for us. It will automatically. So imagine this model to be like a black box. When you fit the model with the data, imagine like putting all of that training data inside that box. And then the box will do its magic. It will do its computations, calculations to help you get the predictions, right? So basically what the model does is it computes all the parameters for the linear regression equation. And after this step is done, we can say that the model is trained. After you train the model, you can compute the accuracy by using model.predict, and then you can verify the accuracy by different measures. So in this case, we are using a mean square error, but typically you can use any different measure. The idea is whatever measure you use the same metric to compare different models. So typically what we do is whenever we work on a problem, we never just make one model. We try multiple models and we see which model works best for that data, right? So you use the same metric to compare how the different models are performing. Okay, so after we make the prediction, we can calculate like the accuracy of the model. So in this case, the test versus predictions, and it computes this mean square error, and this is this 137. And if you want to compute the R score, R2 score or R square score, this is how you can do it. So we can use R2 score method from sklearn.metrics, and you can use the test versus prediction and then compute the R square score. So it's 76 or like 0.76. So to create the model, it's not a huge challenge. So it is generally said that 80% of your time will be spent on just cleaning the data, and only 20% of the time will be spent on creating the model. So we skipped 80% of the time by assuming that the data is all clean. Typically, data cleaning is the part that takes a longer time. That takes a long time because there are so many things that you can test and see. We talked about feature selection in one of the questions. So feature selection, feature elimination, feature extraction, all of these are different things that you can try out and see. So this is what I wanted to show you. Essentially, when it comes down to coding, it doesn't take a lot of time to code that algorithm, like that simple algorithm. This is a machine learning model regression problem solved using linear regression in a very, very, very simple way. So it doesn't take a lot of time to do that. You uh, you need to understand the process, and you need to understand the different concepts which is really important, and you need to test different models out. So this is what I wanted to discuss today. Are there any questions that I can help answer?
We have one question. You can stop sharing your screen now, Himanshu, so they can see us.
Okay.
And let me turn on my camera. The one question is, can the resources for this session be sent out to us? So yes, tomorrow I will be grabbing all of your emails and I will be sending you any resources that Himanshu has. And then right now, I'll actually share with you a little bit more about Himanshu's course. So like I mentioned at the beginning, Himanshu teaches the data analytics course here at IronHack. For those of you who aren't familiar with IronHack, or this is the first time you hear about us, we're a global tech school that spans 3 continents, and we teach courses in web development, UI UX design, and data analytics. And in this course, you not only get to learn the basics of machine learning, like the things you learned today, but you also learn about cleaning the data, extracting data, and my favorite topic of all, web scraping. This is a part-time course, and right now we're accepting applications. And what's really cool about this course is that you get to do it while you have a day job. If you have a job and you want to upskill or you want to start a new career, but you don't want to like quit your job and kind of go cold turkey, Himanshu's course is perfect. It's super exclusive. It only happens every 6 months. So it's better to get in early before it closes. So I'll share the link to the application down below. And if you have any questions about that, you can go ahead and share those in the chat. When you apply, our admissions team does contact you within 24 hours, and it's mostly just to find out what are your interests, what you would like to learn in this course, and how it fits with your schedule. And then from there, they can tell you a little bit more. Himanshu, I don't know if you want to share anything about your course or maybe something about what kind of projects you've seen with your students.
Yeah, definitely. Just to add to it, I know that there are a lot of online courses available, but having somebody in person, not in person, this is going to be a remote class, but that is a lot better than doing a course online. And just to share some of the projects that some of the students have done in the past. They have done some incredible work with AI. Some of the students have even gone beyond what we have taught in class and then done projects which are even more interesting. For example, there was one student who actually made an application using a Spotify API that could take in the data from Spotify API and it could recommend you a song. So based on your preference lists, etc. So there have been like many other applications and models developed by students, like for their final projects, for their mid bootcamp projects, etc. So
totally. I think one of my favorite projects was one of your students that did the weather models. She was like an environmental science major, and she wanted to upskill with the data analytics course. So she basically took that knowledge of her being in kind of a scientific career and used all the things she learned in data analytics to create these really cool models that predicted the weather combined with like climate change over the next couple of months. So people do some crazy stuff. We've seen people with,
there was a student, in fact, in the last cohort, she wanted to buy a house in the near future. So what she did was she developed an application that can scrape all the data from Zillow. She analyzed that data and she made a model out of it. So, there have been like very cool applications that students have developed over time.
And somebody asked here, any further classes that we can have? Himanshu, any more workshops that you want to do with us?
Yeah, definitely. If you guys if everyone like the idea of us having workshops, we can make this into we can have more workshops like this. Definitely, we'd love to have you back.
For sure. And in order to keep in touch with all of those events, in the past we've had an intro to Python workshop, we've had an intro to web scraping workshops, and the best way to stay up to date with those is through our meetup page. So we share those there. I'll share that now in the chat, so you guys have that. We also share them on LinkedIn often, and if you're in our email list, you will receive email reminders of when to sign up for these. so that you can keep exploring topics in machine learning, in Python, all kinds of data analytics topics, but also topics in some of our other courses like web development and UX design. Someone's asking, when is our data analytics course starting? The next one.
Oh,
and for that one, I believe it's June.
I don't have the exact dates, but I can, I can get back on this one.
I'm pretty sure it's June. In the recap email that I will be sending you tomorrow, I'll add the dates so that you have that on your radar.
Awesome.
All right, so we'll stay here a couple of more seconds to see if any more questions come on in. And if you have any comments, let us know in the chat. Did you enjoy this? Did you learn a lot about machine learning? Are you excited to kind of see the world of tech in a different way because of this? Let us know in the chat. And if you're curious, like maybe you want to go into this field, but you're not sure if it's right for you, just know we get tons of people from different backgrounds. Like I mentioned before, we've had people that were in science majors, so anyone that's in biology, chemistry, environmental sciences. We've had people in marketing that want to scale up. As you know, now when you're in marketing, you have to be very data driven. You have to look at the metrics, at the KPIs, and knowing data analytics really helps. And we also get a lot of people who are in finance, surprisingly. That tends to be a really good complement to those skills. So really, anyone of any background can benefit from learning data analytics, machine learning, and so much more with Himanshu's course. Is there a fee for the data analytics course? Yes, just so you know, this is an intensive bootcamp. It is 24 weeks, so that's roughly 6 months, and it prepares you to start a career in the data analytics field. Once you are done with those 24 weeks, you do have a career week where we help you with your resume, we help you with the job hunt, and you are able to build that profile so that you can start applying to jobs and get that career in tech. It's not just like any online course or any kind of self-guided course where you just kind of mildly learn the topics. This is an intensive course that prepares you to have a career in this field. So with the fee, if you apply in the link that I shared below, our admissions team will be able to share all of that information with you. Someone's asking, how hard is it to live from machine learning? So I'm guessing is that a career question? Like how easy is it to make money from knowing these machine learning skills? Can you expand on that a little bit?
Yeah, when I read that question, I wasn't sure like what to answer there.
I mean, like, can you live from it? Yes, you can make money if you get very good at machine learning. I'm pretty sure you can make a lot of money from a career in a career that uses machine learning, if that's your question. But please clarify so that we can give you the proper answer.
And just to add to this, I mean, this course is not just about machine learning. Machine learning is a big part of the course for sure, but we do also teach other different aspects of a student becoming a data engineer, data analyst, or a data scientist. I mean, we work with SQL, we work with different kinds of queries, we work with Tableau as a BI tool so that you can create dashboards, you can create live dashboards, reports, etc. So it's not just machine learning. A data analyst can be, I mean, you can work with you can work like in different areas in a company. You can work as a data analyst, you can work as a data scientist, you can work as a data engineer, depends on, like what your area of interest is. So the course is the skills that you will learn from this course, to put it like very concisely, are like Python, SQL, and Tableau.
For sure. And to add to that, so you guys know machine learning is like the last step in that data analytics career when you go through our course. You have to learn many more topics like Himanshu shared before you can get to machine learning. We shared a little taste of what it's like today, but you have to learn many other things before you can get to that expert level. All right. And again, someone's asking how much our course is. Again, feel free to apply, or right under the box, there is a book a call with our admissions associate button. In that button, you can schedule a call with one of our admissions associates, and they can cover all of the questions when it comes to our pricing for the course, the schedule for the course, and most importantly, our payment options. So with that being said, it looks like we don't have any more questions here. So everyone that's watching still, thank you so much for hanging out with us tonight. Thank you, Himanshu, for giving another great workshop. And stay tuned for all those resources that we'll share in your email tomorrow morning. And just thank you for joining us tonight. We hope you enjoyed this workshop, and we'll see you in the next one.
Thank you, everyone. Have a good night.
Bye, everyone. Good night.